look up at the ceiling of like any commercial grocery store.
Yeah.
Um, Beneath the HVAC conduits, past all the pendant lighting and the structural steel,
Yeah, there are literally thousands of pounds of water suspended directly over your head.
right? Miles of pressurized pipe for fire sprinklers and mechanical systems.
Yeah.
And it's all kept from ripping the ceiling apart by this network of tiny, freely spinning metal rings.
Which is wild because you probably don't even give those pipes a second thought. You just assume they sort of, hover there.
Exactly. But today, we are taking a deep dive into the invisible infrastructure that is literally holding up that modern world.
It's just an incredible feat of engineering hiding in plain sight. Because if that suspension system fails, the building itself becomes a massive liability.
So true. And our source material today is the exact document contractors are using to navigate this invisible network. We're looking at the Iron Pipe Swivel Ring Hanger Buyer's Guide for 2026.
Yes, and our mission today is to decode how this easily overlooked, really mundane piece of hardware is actually an unsung hero. It's fundamentally changing commercial safety, architectural efficiency, and even modern construction budgets.
Okay, let's unpack this, because by the end of this deep dive, you will genuinely never look at an exposed ceiling the same way again.
We should probably establish the physical parameters first, right, before we get into why it's changing construction timelines.
Good call. So what exactly are we looking at here?
Well, looking at the 2026 guide, we are analyzing a highly specific pipe support device. It's engineered to suspend stationary non-insulated pipes from overhead structures.
And it mentions the sizes too, right?
Yeah, the guide notes these hangers cover pipe diameters ranging from half an inch up to 2 inches.
Right, which essentially covers the bulk of standard commercial water and distribution lines. But the defining feature here, the thing that literally gives it its name, is the swivel ring design.
Exactly, the swivel ring.
Yeah, so the hanger incorporates this knurled ring, or like a threaded mechanism, that allows the installer to rotate the hanger slightly. It gives them precise vertical alignment during the installation.
It's all about that micro adjustment.
Totally. I was trying to conceptualize why that matters so much, and it really reminds me of the focus ring on a professional camera lens.
Oh, that's a great way to think about it.
Right. Because when you're framing a shot, you don't pick up the entire heavy camera body and manually shove it a millimeter forward or backward to find focus.
No, you'd never get it right.
Yeah, you just turn that tiny ring to dial the glass into perfect position. You don't rebuild the camera, you just tweak the ring.
That camera lens analogy captures the mechanical advantage perfectly. You're utilizing a micro adjustment to handle a massive macro-level physical burden.
But, okay, I have to push back on the fundamental premise for a second here.
Sure, go for it.
Is it really just a ring that spins? If the goal of this hardware is to suspend a completely stationary pipe, why introduce a mechanism that has play in it? Why do we want a slight rotation in a system that's supposed to be locked in place?
Well, what's fascinating here is that it goes straight to the core physics of a suspended system. A rigid structure is often a very fragile structure.
Oh, really? How so?
Consider the sheer mass we're dealing with. A 2-inch steel pipe filled with water spanning 100 feet of a warehouse ceiling that holds immense kinetic energy.
Wow, yeah, I guess I didn't think about the water weight.
It's heavy. And when you introduce the kinetic shock of, say, a water hammer, or even just the daily thermal expansion and contraction of that steel, the pipe is going to experience micro movements.
Right. And if it's locked into a completely rigid, unyielding hanger,
then all that kinetic energy and thermal stress transfers directly into the rigid anchor point. Or worse, it transfers into the pipe joints themselves.
Sounds like a recipe for a leak.
Or a burst. If a pipe is hung across a rigid system and the alignment is off by even a fraction of an inch, the installer literally has to manually torque and bend that heavy pipe just to force it into the support.
Oh, man. So you're basically preloading the pipeline with mechanical stress before the system is even turned on.
Exactly. You are fighting the natural resting state of the pipe. Over time, combining that preloaded stress with building vibrations and fluid dynamics, it creates shear forces that will eventually tear a rigid hanger right out of the ceiling deck.
That is wild.
Yeah, so the swivel design neutralizes that initial tension. It allows the installer to dial in the vertical alignment so the pipe rests at its natural elevation.
So you aren't just moving a pipe, you're isolating it from the building's structural micromovements.
Yes. It is a vital stress reduction mechanism disguised as a static metal loop.
That reframes the whole concept for me.
Yeah.
And understanding that ability to adjust the system After the hardware's already attached to the ceiling,
Mm.
that leads us directly into the logistical side of the 2026 Buyer's Guide.
Right, because this post-installation adjustability completely rewrites how contractors sequence a job site. It effectively acts as a time machine for contractors.
Yeah, let's look at how the guide breaks down that decoupling process, because it heavily emphasizes the pre-installation capabilities of the swivel ring hanger.
It's a huge selling point.
Because the ring can be dialed in later, an installation crew can mount these hangers into the overhead structure long before the pipe erection actually begins.
Exactly.
Here's where it gets really interesting. It makes me think of hanging a massive gallery wall in your house.
Oh, I like this.
Imagine being able to confidently secure all your picture hooks into the drywall before you even know the exact sizes of the heavy frames. Just knowing that once you hang the art, you have this magic mechanism to dial the height up or down to get everything perfectly level.
That's exactly how it works on site. And translated to a commercial job site, that ability to decouple the installation of the supports from the hanging of the heavy pipes eliminates the single biggest financial drain in construction.
Which is what.
Trades waiting on other trades. Time is literally money.
Walk me through what that clash actually looks like on a site. Like, if we aren't decoupling, how much of a bottleneck is pipe erection usually? Does pre-installing really save that much money?
It's massive. In a traditional rigid installation, the pipe fitters and the structural support crews, they have to share the same physical space on the scissor lifts.
That sounds crowded.
It is. The crew measures the massive pipe, they hold it at elevation, mark the ceiling deck, drill the anchors, set the support, and then finally secure the pipe. It is slow, grinding work.
And what happens if something goes wrong?
If the support crew hits a piece of rebar in the concrete and has to shift their anchor point, the pipe fitters are just standing there idle. And behind them, the drywallers are waiting for the pipe fitters to finish so they can close the ceiling.
So every minor misalignment compounds into hours of expensive idle labor.
Exactly. By decoupling those tasks with swivel hangers, a single worker can go through an entire floor on a Monday and just drill hundreds of these hangers into the deck.
Just boom, boom, boom.
Right. Then on Wednesday, the pipe fitting crew arrives. They drop the lengths of pipe into the swivel rings and simply twist the rings to level the grade. They're working entirely out of sequence.
That is so efficient. And the source material highlights another crucial detail that supercharges that flexibility.
Oh, the insert nuts.
Yes. The guide notes that each of these swivel hangers includes an insert nut, allowing compatibility with reduced rod sizes in accordance with NFPA requirements.
Yes, that is highly specific but incredibly important.
I want to unpack that because insert nut and reduced rod size sound like, I don't know, minor catalog specs.
Yeah.
But they clearly play a major role in the logistics here.
They do because they solve a massive procurement and weight issue. So the threaded rod is the vertical metal bar that connects the ceiling anchor down to the swivel ring.
Okay, got it.
In large-scale fire protection systems, the National Fire Protection Association, the NFPA, they mandate the required diameter of those rods based on the pipe size and the water capacity.
But the guide specifically mentions reduced rod sizes. Why would a contractor want to reduce the size of the structural rod? Isn't bigger always better?
Not when you factor in weight and material cost.
Ah, right. Steel is expensive.
Very. If the NFPA engineering calculations allow for, say, a 38-inch rod instead of a 12-inch rod for a specific commercial run, utilizing that thinner rod across a 500,000 square foot facility saves literally tons of steel.
And thousands of dollars.
Exactly. So the inclusion of the insert nut within the swivel ring means the hanger can instantly adapt to that thinner rod without compromising its grip on a heavy 2-inch pipe.
So the insert nut is essentially an adapter built directly into the mechanism.
Precisely.
So even if the engineering plans optimize for thinner suspension rods, the exact same hanger can stay on the job.
It creates universal adaptability on the job site. The contractor doesn't have to source a completely different class of hanger just because the structural engineer reduced the drop rod diameter.
Which brings up a critical tension in this entire system, I think.
What's that?
Well, we've established that we are introducing vertical movement via the swivel, and we might be using reduced diameter rods, but we're still suspending thousands of pounds of moving fluid over people's heads.
True.
So how do we ensure this flexible swivel point doesn't become the weakest link and just snap? The material science has to be absolutely bulletproof, right?
Oh, absolutely. The material specifications in the 2026 guide reflect that exact engineering challenge. You cannot sacrifice ultimate tensile strength for the sake of job site convenience.
Yeah, looking at the baseline armor on these units, it's serious. The guide specifies they're manufactured from pre-galvanized carbon steel for excellent strength.
That's the core structure.
Right, but then it adds that the hangers are finished with zinc electroplating. And the source explicitly states this is to protect against rust and extend the lifespan, especially in environments heavy on moisture or chemicals.
Yes, the zinc is critical.
But chemically speaking, how does a thin layer of zinc accomplish that? Like, standard paint protects against moisture, so why do we need this complex electroplating process?
Well, paint is merely a physical barrier. Once paint gets scratched, say, by a wrench during installation, the underlying steel is exposed to oxygen and moisture.
And oxidation rust begins immediately.
Right. Zinc electroplating, however, utilizes galvanic protection.
Wait, so we are dealing with the actual electrochemical properties of the metals?
We are. In the galvanic series, zinc is more anodic, or more active than carbon steel. When you electroplate the steel with zinc, you are essentially coating it in a sacrificial anode.
A sacrificial anode. That sounds intense.
It is. If the environment is highly corrosive, like a chemical processing plant or a constantly damp underground parking garage, the corrosive elements will chemically attack the zinc coating first.
Oh, I see.
The zinc literally sacrifices itself, corroding over a very long period to actively protect the structural integrity of the carbon steel beneath it.
That is fascinating. The metal is actively defending the structural steel, not just passively covering it.
Exactly.
And that level of material engineering really explains the massive list of compliance standards we see in the guide. Looking at this list, these hangars are UL listed, FM approved. They meet federal specification WWH 171 Type 10, MSS SP 69 Type 10, and of course those NFPA standards.
Yeah, it's an alphabet soup of regulations, but compliance is heavily mandated. The requirements for commercial infrastructure are unforgiving, and for good reason.
I was joking earlier that this tiny ring has a better resume than I do. But really, why is there such an intense alphabet soup of regulations for a pipe hanger? Is the scrutiny really that high for something so small?
If we connect this to the bigger picture, the stakes involved here are immense. These aren't just holding up basic plumbing. They are required for fire sprinkler systems, HVAC, and industrial mechanical piping.
Right.
Underwriters Laboratories, that's UL and Factory Mutual FM, they are concerned with worst-case scenario survivability. A failed hanger in a fire protection system means catastrophic liability.
So what physical trials does a hanger have to survive to actually earn that UL listing or FM approval? We see those logos on everything from electronics to building materials, but in this context, what are they testing?
To get that FM approval, for instance, a manufacturer can't just prove the hanger holds a static pipe. They have to subject the hanger to extreme physical trauma.
Because if a fire breaks out, the hanger is going to be subjected to intense heat and sudden violent water pressure from the sprinklers activating.
That's just the baseline. They will test the tensile strength by hanging weights that far exceed the 2-inch pipe capacity. They'll pull the swivel joint to the point of absolute failure to ensure the safety factor is massively over-engineered.
Oh, wow.
Yeah, and they will subject the zinc-plated steel to extreme temperatures to ensure the swivel mechanism doesn't warp and just drop the sprinkler lines in the middle of a commercial fire.
Because if the hanger drops the sprinkler line, the building burns down. The liability attached to these small components is just astronomical.
The liability is the driving force behind that entire list of specifications. Meeting MSS SP 69 Type 10 isn't just about ensuring a quality product, it is a legal shield.
That makes sense.
When an inspector walks a commercial site, they are verifying that every single component in the mechanical system meets the federal and NFPA standards. If a contractor tries to save a few cents by using an unlisted hanger, the inspector will fail the entire ceiling grid.
So compliance isn't just a safety metric. It's the bare minimum requirement for a building to legally operate.
Absolutely.
God explicitly compares swivel ring hangers to standard pipe hangers.
Yes, looking at how buyers actually make their decisions in 2026.
Right. And given the massive benefits of strength, flexibility, and compliance we just talked about, why would anyone ever use a standard hanger? Like, standard hangers only offer limited flexibility, moderate ease of installation, and minimal adjustability.
Standard hangers occupy a very specific limited niche. As you noted, they are engineered strictly for basic support.
Reading that comparison, it immediately brought to mind tying down heavy cargo in the back of a pickup truck.
Okay, yeah.
A standard pipe hanger functions like a heavy-duty, rigid zip tie. You wrap it around the pipe, you pull it tight, and it absolutely holds the load in place. But once it's locked, you have zero options.
Right, you can't adjust it.
Yeah, if the load shifts or you need to adjust the tension, you basically have to cut the zip tie and start completely over.
And in contrast, the swivel ring hanger is your precision ratcheting strap.
Exactly. You secure the anchor, load the pipe, and then use the ratcheting mechanism, the swivel, to dial in the exact tension and alignment you need, knowing you can always back it off or tighten it up later without tearing the whole system apart.
That adjustability gap dictates the purchasing decision. If a contractor is running a short, simple line of low-pressure plumbing in an exposed, easily accessible area where thermal expansion is minimal.
Then the cheap, rigid zip tie of a standard hanger might suffice.
Exactly. But the moment you scale up to massive commercial runs, fire suppression systems, or anything requiring precise installations, the standard hanger becomes a liability.
But the guide also serves as a strict warning manual for buyers navigating these complex installations. The ordering specs in the 20-6 guide are incredibly rigid.
They have to be.
To procure the right swivel hanger, a buyer must specifically mandate the pipe size, verify the exact threaded rod size to ensure that insert nut matches the NFPA math, account for environmental conditions for the finish, and match the model number.
It requires a holistic understanding of the engineering plans before a single purchase order is even drafted.
So let's look at the reality of modern supply chains. If a buyer messes up the ordering requirements, say they specify a half-inch pipe diameter but forget to cross-reference the rod size, and the wrong insert nut arrives on site, how badly does that derail a project timeline?
This raises an important question, really, because it paralyzes the site. The scheduling on a modern commercial build is tightly interwoven. If the hangers arrive with incompatible insert nuts, the structural crew can't mount them to the deck.
Which means the pipe fitters can't drop the lines.
And if the pipe fitters aren't running lines, the HVAC trades might be blocked from routing their ductwork because the plumbing footprint isn't established.
Wow, just a total domino effect?
Exactly. The drywallers can't close up the ceilings. The site superintendent now has to scramble to reorder the correctly spec'd parts, which might be sitting on a freight truck 3 states away.
And even if a rogue crew decides to try and force a fit, like modifying the hanger or rod on the fly,
then they void the UL listing and the FM approval instantly. The moment the building inspector sees a modified component that no longer adheres to those standards, they issue a stop work order.
oh, that is brutal.
The contractor is then forced to tear down the installed system, purchase the correct parts, and pay their crews to do the job twice. The incredible long-term cost efficiency of the swivel ring hanger, the ability to decouple labor and speed up installation vanishes instantly due to a single missed line item in procurement.
The hardware is brilliantly forgiving, but the procurement process is entirely unforgiving.
That is the paradox of highly engineered hardware. The precision of the installation phase is completely dependent on the precision of the purchasing phase.
So what does this all mean? We started this deep dive looking at what seemed like, a mundane piece of catalog hardware in the 2026 Buyer's Guide.
Yeah, just a simple metal loop.
Right. But what we've unpacked is a masterclass in mechanical problem solving. The iron pipe swivel ring hanger is far more than a metal loop. It's a highly engineered, code-compliant device that actively absorbs the kinetic stress of massive commercial buildings.
It's an absolute labor-saving device, too.
Exactly. It rewrites job site logistics, acting as a buffer against skyrocketing labor costs by untangling the sequential nightmare of pipe installation. And through the chemistry of zinc electroplating and the rigorous testing of federal compliance, it acts as a structural shield against catastrophic liability.
It really is the unsung anchor point for the fluid infrastructure of the modern world. Without it, the scale and speed of modern commercial construction simply wouldn't be possible.
So the challenge stands for you, our listener. The next time you are standing in a coffee shop or walking through an industrial loft with an exposed ceiling, look past the aesthetic lighting and look at the infrastructure.
Yeah, find the hardware.
When you spot that silver zinc electroplated ring allowing a massive water line to hover perfectly in space, you will know exactly what is happening on a molecular and mechanical level. You are looking at top-tier, efficient engineering quietly doing its job.
And as you analyze that overhead system, it leaves you with a fascinating broader concept to consider.
Oh, what's that?
Well, the swivel ring hanger solves massive logistical and mechanical stress problems simply by introducing a tiny, carefully controlled amount of flexibility into a highly rigid framework.
That's true.
It forces you to look at the rigid frameworks in our own lives, our complex schedules, our career paths, our personal systems, Where else could we benefit from engineering a tiny bit of swivel?
Yeah.
Where could the ability to easily adjust and adapt under pressure without having to tear down the entire structure prevent a catastrophic break?